Alright, so we're continuing our discussion on antiderivatives and indefinite integration. I'm going to first give you some basic integration rules. So take some time, copy these in your notes. I'm not going to actually read them all to you. All you really need to know is that integration is the inverse, it's the opposite of differentiation, and then differentiation is the inverse or opposite of integration. So take a minute, copy these into your notes if you're using a notebook. Otherwise, these are already in the note handout I gave you in class. And then we're going to go and look at the next and the last set of examples. So in our last set of examples, we're going to be looking at solving differential equations. Now, all we're going to do is, in these, actually figure out how do we find the exact c value if we know a point. So all a differential equation is a statement about a derivative with respect to y, where we found a family of functions, we found the antiderivative, which is the general solution. Now our goal is to solve for y with a specific solution given an x and a y value for our constant of integration. So we can actually know what is the function we're looking at. So in example 5, we're going to solve the differential equations given different conditions. So here in example A, we know the derivative is 2x minus 1, and we know that we have a point at f of 2 equals 5, where x is 2 and y is 5. So let's start by finding the antiderivative. So we're looking for f of x. F of x, we're going to increase the power of each variable. So 2x squared, 2x we're going to rewrite as 2x squared, but then divide that by 2 minus x, and then we're going to put a plus c at the end. But we can cancel out these 2's. So we can have this just be x squared minus x plus c. Now, since we know f of 2 is equal to 5, we can set this equal to 5 and replace x with 2. So 5 is going to equal 2 squared minus 2 plus c. And then we can solve this for c. We know 2 squared is 4, and 4 minus 2 is 2, so 2 plus c, that's equal to 5. If we subtract 2, we're going to find that c is equal to 3. So our actual function is going to be f of x equals x squared minus x plus 3. Pretty neat. Alright, let's look at b. We know the derivative is 2 cosine x, and when x is pi over 2, y is negative 3. So first we're going to work backwards. We know that the function where cosine is the derivative, then that function is sine. So when we're looking for our antiderivative, we're going to have f of x equals 2 sine x plus c, and then we're going to replace x with pi over 2 and f of x with negative 3. So negative 3 is going to equal 2 sine of pi over 2. If we use our unit circle, we know that sine of pi over 2 is just 1. So we're going to have negative 3 is equal to 2 plus c. So when we subtract 2, we'll find that c is equal to negative 5, which means our function, f of x, in this case is going to be 2 sine x minus 5. Alright, let's check out a couple more examples. Alright, so still working in example 5, but now on problems C and D. So we know the derivative is x squared plus x minus 7. We're going to start by finding the antiderivative. So we're going to increase the power on each term by 1. So we're going to have x cubed, but then we have to divide by 3, plus x squared, but we have to divide by 2, minus 7x plus c. Now we're going to replace all the x's with 3 and f of x with 1. So we can figure out our c value. So we have 1 equals 3 cubed over 3 plus 3 squared over 2 minus 7 times 3 plus c. Well, 3 cubed is 27, so we're going to have 1 equals 27 over 3. 3 squared is 9, so plus 9 over 2. 7 times 3 is 21, so minus 21 plus c. Now I'm going to take 27 and I'm going to simplify that. 27 over 3, that is just 9. So we've got 1 equals 9 plus, we can write 9 over 2 as 4.5. That's fine. I'm not opposed to us having a decimal in here. Minus 21 plus c. Now if we combine everything, 9 plus 4.5 minus 21, that's going to give us 1 equals negative 7.5 plus c. So we're going to add 7.5 and get that c is equal to 8.5. So that means our function, f of x, is going to be x cubed over 3 plus x squared over 2 minus 7x plus 8.5. If you wanted to, you could also give me all of this still using fractions. Let's look at d. We've got 3x squared minus 4x plus 2 is the derivative, so we're going to find the antiderivative by increasing each power by 1. So we're going to have 3x cubed, but then divide that by 3, minus 4x squared, but then divide that term by 2, plus 2x plus c. Well, the 3's we can cancel out. So we're going to end up with x cubed minus, we can simplify 4 and 2, make it 2x squared plus 2x plus c. So now we're going to replace our x's with negative 1. So we'll have negative 1 cubed minus 2 times negative 1 squared plus 2 times negative 1 plus c, and that's going to equal negative 4. Well, negative 1 cubed, that's negative 1. Negative 1 squared is 1 times minus 2 is just going to be minus 2. Negative 1 times 2, so we're going to have another minus 2, plus c equals negative 4. If we combine negative 1, negative 2, we're going to end up with negative 5. So negative 4 equals negative 5 plus c. Adding 5 to both sides, we're going to find that c is equal to 1. So our function, f of x, is going to be x cubed minus 2x squared plus 2x plus 1. All right, we're almost done. We've got 2 examples left. I think we can do it. So we have g prime is equal to the square root of t, and that g of 9 equals 6, for example E here. So I'm going to start by rewriting the square root of t as t to the half. I just like working with that more. So we're going to now find the antiderivative, g of t. So we're going to increase the power by 1. So we're going to have t to the 3 halves. And when we have a fractional or rational exponent like this, the number that's going to go out in front is the reciprocal of the power. So we're going to go 2 over 3, t to the 3 halves, and then we have to put our plus c at the end. So now we're going to have 6 equals 2 times 9 to the 3 halves over 3 plus c. Now 3 halves, that means we cube the square root of that number. So the square root of 9 is 3. If we cube that, we get 27. So we're going to have 6 equals 2 times 27 divided by 3 plus c. Well, 3 goes into 27. 3 goes into 3 once, and 27 9 times. So we're going to have 6 is equal to 18, because 2 times 9 is 18, plus c. And then if we subtract 18, we're going to see that c equals negative 12. So our function, f of x, is going to equal 2t to the 3 halves over 3 minus 12. And we're done with example E. So let's check out f. We've got the derivative is sine of theta when x is 0, y is 2. So when we're finding the antiderivative, I know that the derivative of cosine is negative sine, which means the antiderivative of sine is going to be negative cosine. So I'm going to have negative cosine theta plus c, and then I'm going to replace f with 2 and theta with 0. So 2 equals negative cosine at 0 plus c. Well, I know cosine at 0 is 1. So I'm going to have 2 equals negative 1 plus c. So I add 1 to get c equals 3. So my function is going to be f of theta equals the negative cosine of theta plus 3. And that actually wraps up our lesson on antiderivatives and indefinite integration.